Today is lesson 14.2 on proportions. Our purpose is to determine if two equations form a proportional relationship so we can apply this skill to real-world situations. So when you work towards a goal, your success is usually proportional to the amount of work you put in, meaning that the amount of work you put in and success have a direct correlation. The amount of time you put in is going to equal more success. So the definition of a proportion is an equation stating that two ratios are equivalent. Two quantities that form a proportion are proportional. An example would be is the ratio 2 to 3 is equal to the ratio of 4 to 6. Notice that I did not read it as a fraction. Proportions are a type of ratio, so you use the word 2 when you are reading it out loud. Okay, so we are going to tell whether 6 to 4 and 8 to 12 form a proportion. We're going to compare these ratios in simplest form. So if I were to reduce the ratio of 6 to 4, it reduces to 3 to 2. And if I reduce the proportion 8 to 12, it reduces to 2 to 3. So the two different proportions that I have are 3 to 2 and 2 to 3. In this case, the ratios are not equivalent because remember, if you change the order, you do change the ratio. So these two ratios do not form a proportion. Okay, another example. Tell whether x and y are proportional. So in this one, we have the graph over here where it gives the value of x to the value of y. So we have the first ratio is 1/2 to 3. When I simplify that, I get the ratio of 1 to 6. And the way I did that was remember that a fraction bar really just means divide. And in a ratio, that bar just means divide. So 1/2 divided by 3, I'm going to keep it, change it, flip it. That means my reduced form is 1 to 6. And I do the same thing with the other one. 3 to 2 divided by 9 means 3/2 times 1/9. I can reduce. And I also get the ratio of 1 to 6. So 1 to 6 does equal 1 to 6. So x and y are proportional to one another. Okay, another way to determine if two ratios are proportional is to find the cross products of each. In the proportion A to B equals C to D, that means the products of A times D and the product of B times C are called cross products. It simply means when I multiply diagonally, I'm going to get the same answer. So in my first example, I have the numbers, or the ratio 2 to 3 is equal to 4 to 6. If I multiply 3 times 4, I get 12. If I multiply 6 times 2, I get 12. So they are equal, which means they form a proportion. Now, when we're talking about algebra, proportions are formed as long as the denominator value does not equal 0. We cannot have a denominator of 0. Okay, let's take a look at one final example. Real life situation here. You swim your first 4 laps in 2 4/10 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? So the first way we can do it is compare unit rates. We have to divide both by 4, and I end up with the rate of 6/10 minute per lap. When I find the unit rate of the other number by dividing it both by 16, I get 0.75 of a minute to 1 lap. So this shows that the unit rates are not equivalent. Okay, let's do it with the cross product and see if we come up with the same conclusion. Okay, so I'm going to multiply diagonally, multiply both numbers diagonally, and I end up with 38 4/10 is not equal to 48 on the other side. So the number of laps is not proportional to the time.